An interesting thing in algebra is that if you have two functions like I have here, f of x and g of x, I can use these functions to build all sorts of new functions. So I'm going to show you how to do that. For example, here, if I have f of x equals x minus 5 and g of x is x squared plus 2x, then I can create functions like f plus g of x, f minus g of x, f times g of x, and f divided by g of x. And those new functions, name those things, are exactly as they sound. So for example, f plus g of x is simply adding together f of x and g of x. So that's going to be x minus 5 plus x squared plus 2x. So when I combine my like terms, my new function, which is f plus g of x, looks like x squared plus, adding my x terms together, 3x, and then I have a minus 5. So there's the new function f plus g of x. Okay, now we want to find the other three functions, f minus g of x, f times g of x, and f divided by g of x. And again, f of x here is x minus 5, and g of x is x squared plus 2 of x, or plus 2x. And so we already did f plus g of x, which we can see right here. So f minus g of x is just simply taking x minus 5 and subtracting x squared plus 2x, right? That's just f of x minus g of x. Alright, so now we just need to clean up and get our common terms. So we have a negative x squared. We have a minus 2x plus x, so it'd give me a minus 1x, and then a minus 5. There's my f minus g of x. Okay, now to do f times g of x, I need to take f, which is x minus 5, times g, which is x squared, plus 2x, like that. Okay, now I'm going to solve this through the FOIL method. So if you remember, that means the first, which in this case would be x times x squared, which is x cubed. The outside, so that's going to be an x times a 2x, which gives me a plus 2x squared. The inside here, which is the minus 5 times x squared, which gives me a negative 5x squared. And then the last terms, which is negative 5 times 2x, which gives me a negative 10x. So now when I just simplify this a little bit, I have x cubed minus 3x squared, right? I had a 2x squared and a negative 5x squared. This is minus 3x squared minus 10x. There's my f times g function. Now, something to point out is, notice that so far, when we get results, they are functions. These all pass the vertical line test. Okay. Lastly, I just need to say, for d part, f over g of x, I just need to have f divided by g. So that's x minus 5 divided by x squared plus 2x. And the only thing I need to worry about here is that I can't have the denominator here be equal to 0. Okay, so x squared plus 2x can't be 0. Now to solve that equation, this is quadratic, so I could factor out an x, and x of x times x plus 2 not equal to 0. So that means x can't be 0 and x can't be negative 2. So what this means is for d part, if this is going to be a function, then I need to add one stipulation, that this is now included or excluded from my domain. I cannot have x to be 0 or negative 2. Alright, but other than that, it's pretty straightforward, right? You just do the indicated operation on your function. Now for another example, just to further our understanding of these new types of functions that we can create, here I have, let's let f of negative 1 equal 3. So I don't know what f is, I just know when the input's negative 1, I get 3. When I input negative 1 into the g function, my output's 4. And negative h of negative 1 is 0, meaning that when I plug negative 1 into the h function, I get a result of 0. And based off that, I want to find these values. So for example, part A, I want to know what f minus h of negative 1 is. Well, based off off my definitions, all I need to calculate then is f of negative 1 minus h of negative 1. Okay, so in this case, that's going to be 3 minus 0, which just results in 3. And it's that simple. I don't know what f and h are. They could be incredibly ugly, but it doesn't really matter. I know that the f minus h function, when you input -1, you get a result of 3. Okay, what about the f times g function? It's the same idea. So here that means I need to take f of -1 and multiply that by g of -1. These are both inputs, okay? Or I'm sorry, they're both outputs with an input of -1. The first one has an output of 3 and the second one has an output of 4. So the resulting output will be 12. In the f times g function, the output is 12 when you insert -1. Okay, for part C here, we have g over h of -1. And so that simply has to be g of -1 divided by h of -1. But this is going to be a problem, right? Because this is 4 divided by 0, and that does not exist. Okay, so here we get a domain error, because remember, when you divide, I know that h of x can't be 0. So in other words, -1 was never something I could plug in anyway into this new function. So here I have no solution. You could say not defined. Alright, now for D part, we have f plus g plus h of -1. So that's a function that is composed of adding all three f, g, and h functions together. This is still a function though, and its output when you plug in -1 should simply be f of -1 plus g of -1 plus h of -1. Okay, so that's going to be 3 plus 4 plus 0, and I get 7 as a result. Understanding that functions are closed in the sense that when I do algebraic expressions on functions, I get new functions is an important concept. I hope these examples make sense. If you have any questions, please let me know, and thanks for watching.